Welcome back to ML and AI Forum from Scratch. This is episode 3 and it's the one of the most important ones in the entire series. In episode 1, we defined machine learning. In episode 2, we learned that there are three types, but if you try to build an ML system today, you would quickly realize that training a model is only a small piece of much larger system. Today, we are going to look at the whole system, the ML pipeline. This is the end-to-end process that takes you from raw data all the way to a working prediction in production. Understand the pipeline and everything else we teach in this course will have a place to live. Let's go into it. First of all, we will move to the agenda of today. Four things today. Why pipeline matters, the six stages of a real ML pipeline, what happens at each stage, inputs, outputs, and pitfalls, and the biggest mistakes beginners make at the each step. So, let me challenge a common misconception first. When most people think about machine learning, they picture training a model, running some code, watching a loss curve go down, and feeling satisfied. That part is real, but it's roughly 10% of the actual work. The other 90% is data collection, data cleaning, feature engineering, evaluation, deployment, monitoring, and retraining. That's where ML engineers actually spend their time. In this industry, a model that's 90% of accurate but poorly deployed is worthless. A model that's 85% accurate but reliably saving predictions to real users is the product. Understanding the full pipeline, not just the training step, is what separates someone who can follow a tutorial from someone who can build something that works in real world. That's what this episode is about. Here are the six stages of real ML pipeline, left to right. Data collection, data preparation, feature engineering, model training, evaluation, and deployment. Each stages takes the output of the previous one and transform it. Raw data becomes clean data becomes useful features, features go into a model, the model gets evaluated, and if it is passes, it gets deployed. Notice the input label on the bottom left, raw unstructured data from the real world, and the output on the bottom right, a model making real prediction in production. That's the entire journey compressed into six steps. One key thing to remember, skipping any stage doesn't make the pipeline faster, it makes it broken. Every stage exists for a reason. We will see exactly why as we go through each one. Initially, we will look at stage 1 and 2. The stage 1 is data collection. This is where everything starts. You are gathering raw data relevant to the problem you are trying to solve. That might be downloading a public data set from Google, querying your company's database, pulling from an API, scraping a website, or collecting sensor data from hardware. The pitfall here is fundamental and famous garbage in, garbage out. If your training data is biased, incomplete, or just plain wrong, your model will be too. No amount of clever algorithm designs can fix bad data. Quality at this stage determines the ceiling for everything that follows. In second stage, data preparation. You have your raw data. Now you need to make it usable. And here's the uncomfortable truth every experienced ML practitioner will tell you. This stage takes 6 to 80% of the total project time. Not training, not architecture design, cleaning data. Real world data is messy. Rows have some missing values, columns have inconsistent formats, numbers are stored as strings, dates are in 5 different formats, duplicate exist, outlier skew distributions. The tasks here are handling missing value, removing duplicates, fixed data types, normalizing or scaling number so they are on comparable scales. In encoding categorical column like job titles or cities into numerical forms. This is unglamorous work, but is the foundation everything else stands on. Let's look at the stage 3 and stage 4. The stage 3 is feature engineering. You have clean data, now you have it smarter. A feature is an input variable your model will use to make prediction. Row columns are rarely the best features. Feature engineering is the art of transforming and combining those row columns into representation that help the model learn more effectively. Some examples: you have a timestamp column. You extract the day of week, hour of day, and whether it's a weekend. You have height and a weight. You compute BMI. You have a job titles as text. You one hot encode them into a binary columns. You have income values that are heavily skewed. You apply a log transform to normalize the distribution. The pitfall: more features is not always better. Everything irrelevant feature you add introduce noise. So the model has to work harder to ignore it. Good feature engineering means being selective, not exhaustive. And the stage 4, which is model learning. This is the step everyone pictures. And now that we have clean engineered data, we are finally ready for it. You split your data into three parts: a training set the model learns from, a validation set you use to tune hyperparameters, and the test set you hold completely back until the very end. You pick an algorithm. We will cover this in depth in later episode. You feed the training data in. The model adjusts its internal weights iteratively, trying to minimize the difference between its prediction and the correct answers. You repeat this until performance stability stabilizes. So the biggest beginner mistake is using the test set during training. The moment your model has seen your test data, your evaluation is worthless. So keep the test set locked away until the final evaluation. Treat it like the answer key, never peek. Another stages are stage 5 and stage 6. The stage 5 is evaluation. Now we have done the training. Now we found out if what you build actually works by testing it on the data the model has never seen. This step demands honestly. It's tempting to keep tweaking your model until the numbers look good. But if you do that on your test set, you are cheating yourself. You are building a model that knows the exam question, not one that can handle new problem. The metrics you use depend on the problem type. For classification, accuracy, precision, recall, F1 score, and the confusion metrics have been used. For regression, root mean square and MAE for are used. For imbalanced dataset where one class is rare, accuracy alone is dangerously misleading. A model that predicts not fraud 99% of the time looks 99% of accurate on a dataset where only 0.1% of transactions are actually fraud. F1 score catches this. We will dedicate a full episode to evaluation metrics later. In the next stage is deployment. Your model evaluated well. Now you make it useful by putting it somewhere real user or system can call it. The most common approach for beginners is wrapping the model in a REST API using Fast API or Flask. A system sensor request with input data, the model returns a prediction done. More advanced options include deploying to cloud platforms like AWS maker, embedding the model inside the mobile app for on-device inference, running batch prediction overnight, or deploying to edge devices where there is no reliable internet connection. The pitfall at this stage is called deployment drift. The real world challenge over time and your model doesn't automatically update. A spam builder trained in 2020 will gradually get worse as a spammers adapt. Monitoring your model's performance after deployment and retraining it with fresh data is a pipeline in itself. We'll cover this in page 5 on MLOps. Here is something important that the linear diagram doesn't show. The pipeline is not a straight line, it's a loop. Evaluation reveals that your model is overfitting. You go back to data preparation and collect more. Your deployed model drifts because real world patterns have shifted. You retrain with fresh data and go through the full pipeline again. You discover a new feature that might help. You go back to feature engineering. In real machine learning project, you iterated through this loop continuously. The pipeline is never truly finished. It's maintained, monitored, and improved over time. This is why understanding each stage deeply matters so much. Now, let's look at the real world examples. Stage 1, collect 100,000 of email already labeled spam or not spam. On the stage 2, preparation. Strip HTML tags, fix character encoding, remove duplicates, handle any null values in the subject or body fields. And the stage 3, engineer. Extract features. Word counts per email, center domain, subject line length, ratio of punctuation to words, presence of certain keywords. And the stage 4, training. Split 80 to 20. Train Navy base or logistic regression classifier on 80%. In the evaluation, run prediction on the health of 20%, measure precision and recall. High recall means we catch most spam. High precision means we don't mark legitimate emails as spam. The next stage is stage 6, deployment. Plug the trained model into the email server. Every incoming message now runs through it in real time. And this 6 stages, one coherent system, that's the pipeline in practice. So in this episode, we have covered all ML pipeline. In the next episode, episode 4 is the environment setup. That is Python, Jupyter, Pandas and Scikit-learn. By the end of that episode, you will have everything installed and ready to write real code. And the episode 5 is your first actual model, linear regression, built from theory to working code on a real dataset. And the next episode is episode 6, covers model evaluation in depth, train test splits, overfitting, and the metrics that actually matter. On this closing off, one sentence to take away from today. ML is a system, not a step. Master the pipeline and the individual pieces fall into place. This 6 steps again: collect, prepare, engineer, train, evaluate, and deploy. Every algorithm we build from episode 5 onward will slot in this framework. When something goes wrong in your model, and you will know exactly which stages to look at. So that's all for today in episode 3. Subscribe if you haven't already. In episode 4 is where we finally open a code editor together. I will see you there. Thank you all.